Welcome back to RSAC Conference 2025. We're here recording live from the CyberRisk TV studio in Broadcast Alley in the center of Moscone West. I'm your host, Matt Alderman. Joining me for this interview segment is Brian Fox, Chief Technology Officer and co-founder at Sonatype. Welcome, Brian.
Thanks for having me.
Little did we know yesterday when we had breakfast that you were going to be up here and I was going to do the interview.
Surprise for both of us.
I know. I didn't realize it until this morning when I looked at my schedule. We're going to talk AI, a lot of people talking about AI, but from this perspective, more about open source AI. Mm-hmm. And so let's start a little bit with kind of the challenges around what are people doing when it comes to AI, the LLMs. Are they hosting it? Are they pulling it down, using it themselves? It's a combination of both. What are you seeing trend-wise on how the LLMs are being used?
It's all of the it's all of the above, frankly. And the area that we focused on, that our customers were asking us to help them with, is to understand when developers are using LLM models inside their applications.
Yeah.
Right. So a lot of the focus is on AI-based tooling around it, that developers might be leveraging to produce better code, Copilot-like use cases,
right.
Chat GPT-like use
right.
cases. But what we're finding increasingly is that the developers are finding these small models that are tuned for specific things useful instead of writing complicated algorithms. And so they pull down these models, bake them in like any other dependency in their software, and then ship it. And so this is sort of, out of sight, out of mind,
right.
is what we're finding. And we're finding, even I was surprised how many times we're finding those in applications. I was thinking, nah, they're not doing that. That's not, and I was wrong. And so, I've been coaching a lot of leaders. If you're not looking for this, if you don't have tools to look for it, just because you don't know it's there doesn't mean it's not there.
Right.
And so that's kind of the part that we're seeing, and we're trying to help people.
And so this obviously mirrors the early days of open source software too. We had kind of the same evolution, right? Yeah. People were pulling down open source software, embedding it into their applications, had no idea it was there. Mm-hmm. Then you realize, oh, it's there. Oh, crud. Now, right. Is it vulnerable? And all the other downstream effects. Kind of same thing here, right?
That's right. When we started solving, this problem, the open source governance problem 15 years ago, we would talk to leaders that said, nope, we're not using any open source. And we run the Maven Central repository. So all the world's open source Java components get downloaded from our infrastructure. And so we'd look at the logs and say, you downloaded 100,000 components from us last year. The fact that you think you're not using open source is a glaring hole, right? Yeah. And it's the same thing, because in their mind at the time, open source was Linux, OpenOffice, Firefox, these
right.
types of things, not the fact that 90% of their software was actually open source. Now, if you ask the developers, of course, they'd be like, yeah, of course we are. Why are you even asking?
Right.
And you get the same response for AI. It's the leaders who aren't aware that this rapid adoption is happening. And so there's the Wild West kind of aspect
right.
of this. And that's what we're trying to help people manage.
Yeah, so I assume this starts with inventory.
It does. If you don't know you have it, how can you even begin to manage it?
So do you use similar techniques in doing kind of software composition analysis techniques to find these libraries embedded in the code? Yeah. Is that where we start?
That's exactly right, because from our perspective, they are just another open source component.
Okay.
They're big ones.
Yeah.
They're a little hairy and a little hard to quantify, but they are at that level just more components, right? So that's why it was easy for us to expand our platform to be able to do that. But what we've discovered as we've looked into this is there's a whole new set of metadata that you care about, right? So when you're thinking about open source dependencies, you tend to think about what's the open source license? Does it have any known vulnerabilities? Increasingly malicious, but that's a little bit of a side conversation. And what are the quality, right? Those are the three typical domains of open source components. When you start thinking about AI, well, of course you have still the license and the vulnerabilities, but now you have to deal with the license. What is the license of the software? What is the license of the model and the data that it was trained on? Might not be the same.
Right.
Right. What are the tuning parameters? And then there's other aspects. OWASP has defined a new top 10, the AI top 10, right? Mm-hmm. So it's things like these components have excessive agency. They can go off and do things, not just talk about things, right? They may be trained on not safe for work data. They may be biased, right? So besides the license and security, you have like all these new dimensions that you need to be able to understand. What are these models? what are the different parameters are they fit for our purpose? You don't want to bake one of these LLMs into your application and have it start spouting off at your customers. Right. And yet that's a very real possibility, because we're seeing these things are in applications and nobody who cares is really governing them. So of course that's a possibility.
So how do you determine those extra components, right? Because unlike a vulnerability, right? These may be more dynamic or somehow buried, right? Like there's not like this library, I don't think, you tell me if I'm wrong, but there's not like this library of, hey, by the way, here's all the LLMs and here's all the different parameters about them, and you just search for those. You have to figure it out somehow else.
It's still, I would say, very much an evolving space. There are metadata that you can collect from certain places. You can understand in some cases what the backstory on the model is, but there are a lot of unknowns, and the fact that it's unknown is a finding as well, right?
Exactly.
So if you can't attest to what these things are and where they are, you need to assume that they might not be safe. But again, it's the visibility, like you said, the discoverability, the visibility is the most important thing, and then you go from there. So I think there's going to be a lot of evolution in the ability to understand and track these things. But one of the interesting challenges around AI is that its power comes from the fact that it's not deterministic, that we didn't have to code every behavior, and yet it does some cool things. That's why we want to use it. Also, that means it's really hard to assess and test. If you take a piece of open source, people don't do this, but in theory, you could read all the code and understand what it does and get comfortable with the fact that there's nothing nefarious in there.
Right.
That's just not possible with AI, because there's petabytes and even more, whatever the next level is, of data in these models behind it. You can't review that. That's just not possible.
Right.
So how do you prove that these things are safe? I think that's going to be a big challenge. And for me, that leads back to a better trust model. If you can't prove all of the things, what you're left with is trusting the people who put the model together, who tuned it, trained it.
This is more of a reputational kind of check first.
That's right.
Like everybody knows DeepSeek, right? You read the license agreement, all that data is going to China, on their servers, right? And so that's pretty easy to go, yeah, you know what? We probably don't want to trust this.
Right, we can't prove it, but you kind of don't feel comfortable about it, right? And the same is true of many of these other components. They might be derivatives of a popular llama model or Anthropic model or something like that, but somebody changed it. Do I trust those people? Maybe it's okay.
Maybe.
But maybe it's not. And that's where I think this ultimately ends up going, and trust around open source is not something we've nailed down perfectly well either.
True, but we definitely know trusted sources to go get open source.
We do, right? For sure.
It still could be nefarious because whoever's developing it could still have nefarious purposes, but we have repositories of places we typically trust to go get open source software. Do we start to build those sources? Are those sources being built in a similar way?
So like the repository, certainly like Maven Central that we run is the trusted source for open source Java. But that doesn't inherently mean that you trust every single person who's putting something in there, right? And in some cases you can, because you start to look at foundations, Eclipse, Apache, these types of things, and they tend to have a better vetting process. It's harder for malicious actors to get things through many eyes. So you can start to layer that trust in. But there's millions of projects out there that are sort of just one or two people that are working on them. They're not associated with a foundation. And as we sit right now, it's very hard to understand who they are. Can I trust them? The XZUtils attempted attack that we saw last year is a case of that, where there was a new committer who was probably a state actor, trying to slip things in. And so like we're just starting to really grapple with this on the open source side. I think actually the need in AI is going to be bigger. And I think the good news is it's actually going to force us to accelerate the whole thing. So whatever we do to solve the trust problem with AI is going to also be applicable to open source. And I think there's probably going to be a step function in our ability to do this. So I think actually it's a good news story as long as we do it quickly. If we leave that door wide open, it's going to be a problem for AI specifically.
Right. Inventory, metadata, what else? Are there other ways to understand? I think the biggest challenge for me is determining what the models do and the outputs of the models and stuff that you can't see until it's running, right? There's only so much you can do statically in these libraries and try to pull metadata, but then when they spin up, do they do something crazy? Do you see this evolution in not only, and we've kind of seen this in application security as well, you've got your static analysis, but then you have to understand what it's doing in runtime and almost compare the two.
Yep.
Like, I expected it to do this is what I analyzed statically, here's what it's actually doing. Do they align? And it's the yin and the yang of the runtime versus the stack. Is that where we have to evolve in this space a little bit?
Yeah, I think that's, we talked about that yesterday, right? That I think there's going to be an increased need for behavioral analysis on the runtime to detect the anomalies, because if a prompt is causing the system to do something nefarious, it's probably going to show up in the amount of CPU and processing that is happening for that prompt.
Right.
It would hopefully look like an outlier, right? So I do think for the models and the behavioral analysis, because it's not deterministic,
right?
But you can kind of start to build trends of what's normal. And start to look for the outliers. So yes, I do think that that's going to be, it's almost by definition going to be the equivalent of SAST and DAST on our normal code side.
Yes.
The only way to really understand it is at the runtime.
Yeah.
So I think it will sit in that same spot of the portfolio as sort of like belt and suspenders of understanding when something goes wrong.
Yeah, I can see that evolution. Companies that are struggling this, where should they start? Like, where do they start? Do they start with policy, I think, or do they start with inventory, then put in policy?
Yeah.
Like, okay.
You need to start with inventory, defining the policy. They will say we have a policy of it not being used.
Yeah, right.
Until you can do the inventory authoritatively, how do you even know if your policy is even effective? So once you do the assessment, you get the inventory, then I think it provides the motivation to actually define and enforce the policy, not the other way around.
Yeah.
Because they've effectively done it and it's not working. And we saw the same thing with open source.
I know. I
you can't
saw
use open source, and yet 90% of your software was open source.
Like 2 years ago, we saw this huge uptick and people were like, oh, it's all about AI, and everybody was rushing to try to test stuff, and then organizations went, whoa, time out. We're going to put policies in place. We're not going to allow you to do this until we understand the potential concerns around this. But it didn't matter because people are still doing it anyways.
That's exactly right. And that's where the inventory, the visibility becomes important.
Yeah.
Because without that, how do you know? How do you know that the policy is being followed? You could just make an edict and that's nice. It's not worth the paper it's written on.
Correct. Yeah. Well, I mean, that's always been part of the fun in security in general.
That's
anyways,
right.
is alignment to policy. One last question. How much intellectual property concern should organizations have in their core software by using these other types of LLMs? Because I know building a software product, there's certain license types I stay away from because they get me into IP trouble. I assume the same thing exists here?
Oh, absolutely, yeah. I mean, the license of the data is very important there.
Yeah.
But if you're worried about the IP of your stuff, that's a new dimension, one that's covered by that top 10. Understanding, is your data going back to a service? Is it being streamed somewhere? Because in these AI models, the power comes from exposing it to your data. So it's almost worse than a piece of software that might be siphoning one or two things in the old model. In this model, you're just like handing it everything, your whole source code potentially, all of your data. Again, that's where the power, it's by definition, you need to do that. But if you can't trust it, you don't have the data about what's happening. Is the model training off of the back end of that? You can never get that data back. It goes into the model and it's there forever, right? So yes, that is one of the big fears, and that's why you really need to be careful about that. And imagine you were building a healthcare application, your developers put some model in there for a very small thing, but it had access to all the customer input data. Now you're talking health records, for example.
Exactly.
Right? That your developers didn't have access to, but at runtime it does. Now, if all that's being shipped off and trained on, that could be a really big problem.
It's not just an IP problem, it's potentially a privacy breach problem,
Exactly.
too. Yeah.
Right, it's both. It really depends on what data is being funneled into that particular LLM.
Yeah, scary stuff. Always a pleasure, Brian.
Yep.
Thanks for joining us.
Thanks for having me.
If you want to learn more, please visit securityweekly.com/Sonatype, RSAC. Brian, scary but good.
Yep.
Thank you for joining us again. All right, folks, stick around. We got more interviews coming here live at RSAC Conference 2025.